Hey guys, welcome back to the channel. So for today's video, we will be continuing where we left off. So let's start off with Bandit 21. So let's take a look at the objective for Bandit 21. It says that a program is running automatically at a regular interval from cron. So cron is basically a time-based job scheduler. Let's check out the cron D directory. We are interested in the cron job for Bandit 22 since that is the next level. Okay, so there's a shell script that will be executed by the Bandit 22 user. Let's check out the content of the shell script. So this is a shell script file. There's a chmod command to ensure that the temp file will be readable by all other users, and subsequently there is a cat command that will read out the password for Bandit 22. The output will then be redirected into the temp file. We can see that if we were to read the password file directly, there will be a permission denied error message because only the Bandit 22 user will have the permission to read the file. If we were to read out the temp file, we should get the password for Bandit 22. We should be able to do so since the temp file is world readable. This should be the password for the Bandit 22 user. Let's try and authenticate with it. We were able to solve Bandit 21 just by reading the content of the shell script file. It is recommended to read the man page or even the wiki page for the cron job to understand the syntax and how it works. Let's move on to Bandit 22. Looking at the description, it should be related to the cron job again. So let's check out the cron job for Bandit level 23. Let's check out the content of the shell script. There are two variables in the shell script, my name and my target. My name will contain the value of the command who I am. In this case, it will be Bandit23, since the shell script will be executed by the user Bandit23 via the cron job. Let's analyze what will be the value for the variable my target. So we can see that first, there will be an echo command that outputs I am user Bandit23. The output of the echo command, which contains the string I am user Bandit23, will then be passed on to the command md5sum. md5sum will perform a md5 checksum on the string I am user Bandit23. This should return a 32-bit hash value from the md5sum command. The name of the temp file will be the value of the my target variable. Let's try and read out this file name in the temp directory. We should get the password of Bandit23 in this file. This should be the password for Bandit23. Let's try and authenticate with it. We were able to complete Bandit 22 just by understanding the content of the shell script again. Let's move on to Bandit 23. Bandit 23 is another cron job challenge. This level will require us to create our own shell script. Let's check out the cron job for Bandit 24. Let's read out the content of the shell script belonging to Bandit 24. My name variable will contain the value of Bandit24, since the shell script will be executed by Bandit24. The shell script will then change directory to the /var/spo/bandit24/full directory. We can see that the directory exists, but we are unable to list any files in the directory. Continuing with the shell script, we can see that there will be a for loop that will execute every files in the /full directory. It has an if condition to ensure that the files that are executed is not the dot and the dot directory. The script also checks if the owner of the file is Bandit23 before executing it. So this means that whatever files that we put into this /full directory will be executed by the Bandit24 user via the cron job. Let's create our own working temp directory since we will be creating a shell script file. What we can do here is to have a shell script that will read out the password for Bandit24. If we try to read out the password for Bandit24, there will be a permission denied. But the shell script should be able to do so since it will be executed by the Bandit24 user. Let's create a password.txt file so that the password of Bandit24 can be redirected into this text file. We will then be able to read the password.txt file to retrieve the password for the Bandit24 user. Let's ensure that the file is writable for all users. This is to ensure that Bandit24 has the permission to write to this password.txt file. Let's create the shell script now. The shell script will be very simple. We will just need to read out the password for Bandit24. The output, which is the password, will then be redirected into the password.txt file that we have just created. This will work because the script will be executed by the Bandit24 user instead. So the script will have the permission to read out the password for the Bandit24 user. The password.txt file is word writable, so Bandit24 will be able to write into this text file. We need to ensure that the script file that we have just created can be executed by Bandit24 as well, since this will be done via the cron job belonging to Bandit24. Let's set the right permissions for our script file. We need to ensure that Bandit24 can execute it. The execution bit is now set. Bandit24 will be able to execute it. Let's copy the shell script to the full directory. The shell script has been successfully copied into the full directory. The cron job belonging to Bandit24 should execute the shell script soon. Let's look at the password.txt file. We can already see that there is input in password.txt file. This should be the password for the user Bandit24. Let's try and authenticate with it. We managed to solve the challenge by creating our shell script that will be executed by the cron job of Bandit24. Let's move on to the next one. Okay, so for Bandit24, we will need to connect to a network service on port 30,002, and we need to perform a brute force attack. So it says that we will need to submit the current password followed by a 4-digit PIN code. We will need to go through the 10,000 combination of 0000 to 9999. So let's try and connect to the network service on the port 30,002 to see how it looks like. We can do so by using the telnet command. So let's try and connect to the network service. We can see that we will receive a banner message. We can then submit our input. Okay, so the network service will respond with a wrong message if the PIN code is incorrect. We can also connect to the network service by using netcat. Let's try that out. We can see that we will receive the same banner message. We can also submit the password and the PIN code. If it is wrong, the network service will respond with a wrong message. Let's try and solve this by using Python. Let's try and Google how we can do this. So we will need to use Python socket to create a TCP connection to the network service. We can Google for this, and we can make use of an existing template and build on top of it. We can change directory to the temp folder and create our own directory to work on. This Python TCP client that is created around 6 years ago looks like a good template that we can use. Let's try and work on this template. Let's copy the Python code and create a Python file. First, let's change the port number to 30,002 as well as the IP address to point to localhost. This will be where our network service is listening at. We can also change the data that will be sent to this network service. We will need to keep the \r and \n. This means to send the payload by pressing the enter key. Let's keep a placeholder of the string payload now in the data that we want to send. Let's create a variable password that will contain the password of the current user that is required in the input. Let's create another variable called message. So the message will be the data that we want to send. The message should contain the value of the password and the space followed by the numeric 4-digit PIN code value. Let's set this to the pin code variable. We will also need to send the \r\n so that the data will get submitted. This means to press enter, which is to submit the data once we are connected to the network service. Next, we can Google how to do a for loop using Python. On Stack Overflow, this seems like a perfect code to use. Let's copy this and use it. Let's set it to 5 so that we can see how it works first instead of having to go through all 10,000 combinations. We will need to indent the code properly so that the syntax will be correct. Since we know that once we are connected to the network service, there will be a banner message. Let's create a variable for that and print it out. Let's try and run the Python script. Okay, there is an error. It appears that we have not set the pin code variable. So let's set the pin code variable to point to the value of I, since I is used as the for loop. So now the pin code should contain the value 0000 to 9999 as the loop is being executed. We can see that it is successful and we managed to send 5 payloads. So this will be a problem because we have to go through 10,000 combinations. If we have an output like this, it will flood our terminal with the wrong message. We will need to create an if condition to only print out the output if the response received does not contain the keyword wrong. This means that if we encounter a response from the network service that does not have the word wrong in it, we want to know the output, as well as to print out the attempt so that we can know the correct pin code. Let's Google how to do that in Python. This seems like the perfect solution to what we are looking for. We should be able to use this if substring not in string condition. We want to check that the substring value wrong is not in the response received. To ensure that this is working as intended, let's try out the if condition when the keyword wrong is in the response. We know this is definitely true because we already know the output from the network service. If the substring wrong is in the response, we should then print out the output. Let's define the substring to be the value wrong. We can see that this works as intended. The if condition is able to print out the attempt, which contains the pin code value, as well as the output, which contains the wrong message. So now we can change the if condition to be not in instead. So this should now only print out the attempt, which contains the pin code, as well as the response from the network service, only when the response does not have the keyword wrong in it. Let's change the loop now to be 9999 so that we can attempt all 10,000 combinations to brute force the pin code. So we will need to let this run for a while as it could take some time. The waiting time will be edited out. After a long wait, we can see that we managed to get the pin code value 9458. And the response from the network service, which does not contain the substring wrong, is printed out as well. So when the pin code submitted is correct, the network service will actually output the password for Bandit user 25, which is what we want. So this is the Python script that we use to brute force the network service. The content of the script will be pasted in the video description. Let's exit and try and authenticate with the password for Bandit user 25. So we can see that it was successful and we managed to clear Bandit level 24. Now let's move on to Bandit level 25. The description says that logging in should be easy. We just need to use the SSH key to log in. But the shell for Bandit 26 is not the typical bash shell, but something else. We can check out what is the shell for the user Bandit 26 by looking at the etc password file. As we can see, Bandit 25, or typically for all users, will be a bash shell or a sh shell. But for the case of Bandit 26, it is actually a show text binary. Let's check out the binary. So the binary will execute a more command, which is to read the text file and exit immediately, which is why we should not be able to log in as the user Bandit 26, since after reading out the text file, which I assume is the banner message, it will be exited immediately. So we will not be able to get an interactive session of Bandit 26 because of the exit command. Let's try this out. Let's change the permission of the SSH key so that we can use it. We can see that the connection is immediately closed because of the exit command. One thing that is interesting is actually the more command. So the more command actually allows breakout. So we should be able to break out of the more command and spawn an interactive shell. One useful page that we can check out is the GTFO Beans GitHub page. If we search for the more command, it can be seen that this is documented as well. So the more command can be used to break out from restricted environment by spawning an interactive shell. We can use the !bin/sh for example to spawn a shell and break out of the more command. Let's use the more command to read the etc password file. We can see that there's a --more --prom at the bottom of the file. This is because the more command is not able to read out the entire content in one page because the etc password file is longer than the terminal size. With this prompt, we can then input the !bin/bash for example to break out of the more command and spawn an interactive shell. We can see that when we exit, we are back to the more command. Let's exit from the Bandit 25 session and we will SSH directly as the Bandit 26 user from our host machine. We can see that the connection is immediately closed because of the exit command. We will not be able to get the --more --prom because the more command is able to read out the entire text file. What we can do is actually to resize the terminal so that the more command will not be able to read out the entire text file. This should then gives us the --more --prom that we need in order to spawn an interactive shell. Let's try and resize it even more. Great, we are able to get the prompt now. We should be able to break out of the more command and spawn an interactive shell. This should give us a session as the Bandit 26 user. The !bin/bash didn't work. This should work as we have demonstrated in the etc password file example. Let's press the button H on the keyboard to see the help page of the more command. We should be able to append an ! followed by the command that we want to execute. However, in this challenge, this did not work. Another interesting thing that we can do is to start up a file editor VI. So VI should allow us to execute our own command such as spawning an interactive shell. The VI file editor is documented on the GTFO bin page as well. we can use the :set shell to set our shell to be the /bin/bash, following which we can then submit the :shell value. We now have an interactive shell as the Bandit26 user. And I will see you guys in the next video.